I'm Anil Kumar. Welcome to my series on related rate of change. Here is a very important example where we are going to learn few basic concepts. We'll see how displacement, velocity and acceleration are related. We'll also understand the terms about stationary objects, objects moving away or coming closer, or speeding or slowing down. So let's look into the question now. A particle moves in a straight line so that its displacement, s meters, from a fixed origin after t seconds is given by s of t equals to t cube minus 2t square plus t, where t is greater than or equal to 0. We need to find all these things, 6 parts. A. Determine particle's initial velocity. B. When is particle stationary? C. Once the particle starts to move, how many times will it pass through the origin? D. Is the particle moving away or towards the origin when t equals to 0.5 seconds? E. Is the particle speeding or slowing down when t equals to 0.5 seconds? F. Determine the total distance, not displacement, traveled in the first 5 seconds. You can actually pause the video, answer these questions, and then look into my suggestions. So let's begin with the very first part, which is determine particle's initial velocity. Now we are given displacement s of t is equals to t cube minus 2t square plus t. Velocity is derivative of displacement. So we can write velocity as equal to the first derivative of displacement. We sometimes get this example in the chapter relating higher derivatives, right? Since acceleration will be the second derivative for velocity. So the derivative is going to be 3t square, application of power rule, 4t plus 1. Part A is determine particle's initial velocity. That means this velocity, which is now a function of time. Initial means when t equals to 0. So basically we want to understand what is the velocity when t is 0. Right? So substituting 0 here, we get 3 times 0 minus 4 times 0 plus 1, which is 1. Right? Units being meters per second. So that is part A. Clear? So we've done part A, and the answer is 1 meter per second. Let me highlight. So we can write initial velocity. Okay, now let's look into part B. When is particle stationary? Now, when we talk about stationary, it means what? It means particle is not moving. So we are trying to figure out when is velocity equals to 0. This is what we are trying to find. Perfect. So let us see how do we do this part. We'll begin with the equation which relates velocity. So velocity we found is 3t square minus 4t plus 1. So which is 3t square minus 4t plus 1. Now let's factor this. We could write 4t as combination of 3 and 1 with negative sign, right? And now we can factor 3t from the first two terms. We get t minus 1, and we already have t minus 1 as another term. So t minus 1 is one factor. 3t minus 1 is the other factor. When will this be 0? So we will not try to figure out when is this equal to 0. That is what we mean that particle is stationary. Clear? So we have two times when t equals to 1, this will be 0, and when t equals to 1 over 3, that will be 0. So those seconds, time is in seconds, is our answer. Perfect. So we got two parts. Now we'll move on and try to understand, once particle starts to move, how many times will it pass through the origin? When we say pass through the origin, means what? That means at that time, S of t should be equal to 0. Is that okay? So we'll look into this and then answer the other parts of this question. Now let's look into part C. We are given that the displacement is t cube minus 2t square plus t, where t is greater than or equal to 0. The question is, once the particle starts to move, how many times will it pass through the origin? So origin means point when displacement S of t equals to 0. That means particle is at origin, right? Perfect. Now the key here is, how many times will it pass through? That means it has to cross the origin. Is that okay? It has to, that means cross origin. So that is, I think, a key of understanding. So we are assuming how many times will it cross origin, not how many times will it be at origin. So I hope that part is absolutely clear, right? So let's begin with the equation itself, which is t cube minus 2t square plus t. So if you factor t, you get t square minus 2t plus t. Now this is a perfect square, so you could write this as t minus 1 whole square. And we know t is greater than or equal to 0. Now in that scenario, when t is greater than or equal to 0, in that case, we know it is non-negative, right? So this part is always positive. This is also positive. So that means it is non-negative. Since the expression is non-negative, we do get an answer, which is that it will never pass through. It is always non-negative, correct? Now to explain you this situation, it is kind of like this. Let us say this is t equals to 0, and at t equals to 0, we know position is like 0, 0. The object is actually moving in a straight line. So it's a uniform rectilinear motion kind of thing, right? It's moving along a straight line. So what we are doing here is that as time passes, we are tracking distance from a particular position, which is called the origin for us, right? So we do notice that the particle moves away, since it is always positive, right? Particle moves away, it does turns, comes back to 0, and then again moves away, right? So that is the kind of movement we have seen. And clearly it comes back here at starting point t0 when t equals to 1. So somewhere it turns, right? We still don't know when it turns, but we know for sure that at t equals to 1 seconds, it comes to this point and then moves away. So this is, we are showing displacement S of t with respect to the starting point origin. So I hope that part is clear, correct? Since it never crossed and came to the negative side, we are saying that it never crosses. So never passes, so non-negative. And so my answer for this will be 0 times. It will cross origin. So that means never. Is it okay? So that is how I'm going to interpret and answer this particular part of the question. I hope that's absolutely clear. Now this is part D of our question. We know that displacement is given by t cube minus 2t square plus t. Is the particle moving away or towards the origin when t equals to 0.5 seconds? So how do we figure out whether it is moving away or towards the origin, right? Now here there is a concept. That is to say, if the product of displacement and velocity is greater than 0, then it is moving away from origin. Very important concept. And when the product of displacement and velocity is negative, then it is moving towards origin. The starting point, I mean, in this case. So I hope you understand this particular concept. Now it becomes simpler. So we know time is half second, 0.5, right? So S of t is given to us as t cube minus 2t square plus t. So we can find what S of 0.5 is, right? So that is 0.5 cube minus 2 times 0.5 square plus 0.5. Correct. As far as the velocity is concerned, we found that velocity is derivative of this, which is 3t square minus 4t plus 1. So we'll find also velocity at 0.5, which is 3 times 0.5 square minus 4 times 0.5 plus 1. Correct? So let's use calculator and calculate this out. So we have 0.5 cube minus 2 times 0.5 square, and then we have plus 0.5, that is equal to 1/8. On the other hand, for velocity, we have 3 times 0.5 square minus 4 times 0.5 plus 1, and that is equal to, this is equal to minus 1/4. Right? So the velocity is negative 1/4 at t equals to 0.5 seconds. Now, if I multiply these two, that is displacement at 0.5 times velocity at 0.5, I get 1/8 times minus 1/4. So definitely it's a negative thing, right? So order doesn't matter. Since it is negative, we say it is moving towards origin. So at t equals to 0.5 seconds, it is moving towards origin, right? So I hope that part is absolutely clear. Now let's look into part E. For the displacement given as t cube minus 2t square plus t, is the particle speeding or slowing down? So this time we'll look into the concept of speeding or slowing down when t equals to 0.5 seconds. So let's rewrite our equation. We know S of t is equals to t cube minus 2t square plus t. Velocity is the derivative, 3t square minus 4t plus 1. Then acceleration is actually derivative of velocity, right? So we get 6t minus 4. So what is the concept for speeding or slowing down? So for speeding and slowing down, the concept is that the product of velocity and acceleration should be, if it is speeding, it has to be greater than 0. And for slowing down, this product should be less than 0. Extremely important concept to remember, right? So, I mean, it will make sense also if you rationally think through it, you will understand. I'll recommend you to watch some of my videos where I'm talking about this concept, correct? Now, since time given to us is 0.5, we'll just substitute that for velocity and acceleration. So velocity for 0.5 is 3 times 0.5 square minus 4 times 0.5 plus 1. And we found this was negative 1/4, right? Now let's calculate acceleration as time is 0.5. So if I write 6 times 0.5 is half, right? Let me write half here. It's easy to use fractions. What do you get? You get here, let me write here. We get here 3 minus 4, which is negative 1. Since it is negative, acceleration, right? And that is also negative. So what do we have here? So if you relate, what we get here is that v of 0.5 times acceleration of 0.5 is actually minus 1 over 4 times minus 1, and that is actually equal to positive 1 over 4. So it is positive, correct? Positive means it is speeding. Perfect. And therefore, we can write down our answer, which is at t equals to 0.5 seconds, the particle is speeding. So I hope the explanation is clear. Now, to understand why all this, you could actually look into my videos where I'll explain that in more details. So let's move on and find the total displacement for the first 5 seconds now. We are almost at the end of our video. Now here is solution to part F. We are given the displacement function s of t equals to t cubed minus 2t squared plus t, where t is greater than or equal to 0. We need to determine the total distance traveled in the first 5 seconds. So let's rewrite the displacement function, which is t cubed minus 2t squared plus t, and its derivative, velocity, will be 3t squared minus 4t plus 1, which can be factored and written as t minus 1 times 3t minus 1. Now it clearly indicates that there are 2 turning points here. So that means v of t equals to 0 at t equals to 1 and at t equals to 1 over 3. So if you're looking for the motion in 2 dimensions, I could actually sketch it along this line as first, when s is 0, then the displacement is also 0. So at these times, let's find the displacement, right? So we'll have s of 0, which is 0, substituting 0 here. Then let's find what is s of 1 over 3. So we can substitute 1 over 3 here. We get 1 over 3 whole cube minus 2 times 1 over 3 whole square plus 1 over 3. And we'll also calculate what is s of 1 equals to. So if I substitute 1, I get 1 minus 2 plus 1. This is indeed 0. We checked it out earlier. Since we need up to 5 seconds, let's find what is s of 5. S of 5 will be 5 cubed minus 2 times 5 square plus 5, correct? So let's use calculator to calculate these answers. So within brackets, I'm putting 1 divided by 3 cube minus 2 times within bracket 1 divided by 3 square plus 1 divided by 3 gives you 4 over 27. So this is 4 over 27. This is 0. And let's calculate s of 5, which is 5 cube minus 2 times 5 square plus 5, and that is equal to 80. Okay. So that will help us to show the diagram. So initially s is 0, so the object starts from, let's say, this point and moves forward for 1/3 of a second, right? So it moves forward and it reaches a point where t is equal to 1 over 3 and 3, and s is equal to 4 over 27. Now at this point the object turns, goes back now, and it returns to a position where the displacement is 4 over 27, right? So that happens at so it returns after 1 minute. So at this point t is 1 and the object is right there at the starting point, right? So this is what happens when t equals to 1, displacement is 0. Then again it moves forward from here and it kind of reaches somewhere. At t equals to 5, we have s equals to 8t. So from here you can calculate the total distance traveled. Do you understand? So distance is really sum of all this. Sum of absolute values. Correct? So let's count. So the distance d is equal to, so first moving forward 4 over 27. Correct? So that much it moved forward. Then it came back the same distance, right? So again 4 over 27. That makes it 0, right? So 4 over 27 going forward, 4 over 27 coming backwards, right? Change in displacement is the distance in this case. And then we'll add 80. So that becomes the total distance. So let's add them up. So we get 4 divided by 27 equals to, we'll add this with 4 divided by 27 again. That is 2 times 4 divided by 27, and to this we'll add 80. So in decimals we get approximately 80.3. The units are meters. So that is how we get the total distance for the object to travel in 5 seconds. Is that clear? Right? So I hope you have learned the technical terms related to when is particle stationary, when will it go through origin, when is it going away or coming towards the origin, and also the concept of speeding and slowing down, along with calculating the distance, not displacement. Perfect. So with this we end our video, and I hope all these concepts are absolutely clear. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that will be great. Thanks for watching and all the best.